1. Is that short enough 1? And down here, if I square, where am I? Yeah, square here, square 1, you'll get 1. That says, what the statement says, that's true. Is that a function? No, because these two do what? You got 1 paired up with a -1, and all of a sudden you got 1 paired up with also what? A +1. That can't happen. That's not a function. I thought someone in class yesterday, I think, told me they knew what the shape of the graph on this was. I know the shape here. We know the shape here. Someone remind me what the shape here was.
Horizontal.
As a horizontal. I'll just do it right quickly, something like that, which would not pass the vertical line test. Last one. Would this, can I classify it as representing a function? If so, I'll go back and somehow put an f of x in there. Can I? If you say no, you gotta show me an example why, like I did here on this one. Does anyone have an idea what couple of ordered pairs you could create for me right quickly that would satisfy this, but also show me it's not a function?
4, 1, 1, 4.
Okay, then again now. If you let x be 4 or y be 4?
What's up?
Which one? X squared plus y squared is equal to 4. What would you like for the ordered pair? Give me an ordered pair.
4, 1, -4, 1.
Okay, now hang on now. Let x be 4. Now if you let x be 4, I see 16. You may have it backwards. Is it? I can't use 4. That'd be a 16. Give me an x and a y that you think would satisfy that expression.
2 and 0.
To begin.
2 and 0.
2 and 0. You let x be 2, 2 squared is 4. Let x be 0, y squared is 0, and that's 4, and that's what I wanted. Is there another possibility? And I know one possibility would be, could I have another possibility like that? If I let x be a -2, is that squared? 4 plus 0, does that also work? Okay. So it looks like right now I've got 2 paired up with 0. That's beautiful, as long as I don't have 2 paired up with anything else. A -2 is paired up with 0. That's beautiful, as long as I don't have -2 paired up with anything else. Now, can I say just based on those two, that's a function? Okay, someone give me another case that may show no, it's not a function. Now I'll get my lesson started here shortly. Help me out, guys.
0, 2, 0, -2.
Hang on. Zero, 2, 0 squared, beautiful. 2 squared, 4, beautiful. This one, 0 squared, 0 drops out. -2 squared, 4. They do satisfy, right? Is it a function? No. I paired 0, or he paired it, 0 up with 2. All of a sudden he paired 0 up with another number. You can't do that for a function. Therefore, x squared plus y squared is equal to 4. It's not a function. Can anyone, just out of curiosity in this class, I know that this one was a parabola. The shape, the graph. This one a student gave me yesterday is a sideways parabola. Does anyone think they know what that thing would graph into? And it will not pass the vertical line test. Does anyone know what x squared plus y squared is equal to 4 graphs into? Is it a straight line? Parabola? Something maybe, what is it? Who has an idea? X squared plus y squared is equal to 4. Its shape is? Wow. Mr. Park, I know you're still just back from your trip. Tell us, class, what you think x squared plus y squared equal to 4 would graph into.
Circle.
A circle. A circle. Now, well, not graph it precisely. It's going to graph it to a circle. Now, would that pass the vertical line test?
No.
Definitely not. You'd have 2 points of intersection. Okay, I would throw, I just want to throw those out there, let you know what's a function and what's not a function, okay? Now, with that said, now I'm ready for my student to help me. Guys, I'm gonna erase all this is nice, just for a little intro. Now I'll call this part one, like I'm really getting started here now. Now, the part I'm looking at for the handout on functions is this. The one you have the handout. Could I have a student in part two, I need part two, where I gave you a function, I gave it to you, then I ask you some questions. Who would like to read for me? I see someone up front, but can read anyone. Go for it.
For each x.
Yeah, name the function first one.
F of x equals negative 2.
Hang on, my marker messed up. Okay, f of x is equal to,
Negative 2x squared
negative 2x squared
plus x minus 1.
minus 1, like that? Did they say graph this? No. But you can see some of these on the exam. Every student will get this part on the exam Friday correct. Why? Well, they asked me to find first. This is given. Find what was it? Now read that to me. Find what, number one?
Find f of 0.
Oh my goodness. What does that mean? You're gonna go through and replace those x's by 0. I know I shouldn't have to do this, but since we are here, I will do it. It looks like we're gonna end up with a negative 1. Okay. That's all I want. I'm done. 100%. Now, can anyone tell me, you know how I teach, I want you to make connections. We're finished, but can anyone tell me something else about what I just discovered? Negative 1, I'll give you a check and get 100%. But tell me something else that I just discovered.
Your x and y.
I discovered the x and the y. The x was 0. And guess what the negative 1 is?
Y.
Y. You just discovered, look at this, that point will be on the graph of, guaranteed, on that graph of that quadratic. I'm not going to ask you to do that for me right now. I just want the negative 1. Guy, tell me what number 2 is.
F of negative 4.
Negative 4?
Yes.
Okay, it's replaced by negative 4. Be very, very cautious here. Now, if I don't mess up on my arithmetic, guys, I think the first term is negative 32. You got minus 4, minus 1. Do not let me mess up myself here. Is that negative 37?
Yes.
You're done. That's all I want. We're done. You say, Professor, if I were a student in class, I'd say, Professor, give us lots of these, please. One whole page of the test Friday. Please, like this. Please do it. What's the next one?
F of 3 over 2.
F of 3 over 2, not too bad. A fraction. Here goes, negative 2. 3 halves squared plus 3 halves minus 1. Just gotta be a little careful here. Guys, that's a negative 2 times 9 over 4. Let me just rewrite. Out front, do a little canceling. You could call that negative 9 over 2, no problem. 3 over 2. And if you're really, really, really eager to do this, I'm gonna go ahead and write that 1 as 2 over 2. So everything's over 2. That's one way to deal with it. Put them all together with a common denominator of 2. So on the top there for my numerators, negative 9 plus 3 is what's negative 6 minus 2? Is that negative 8? I did that real quickly. Is it negative 8? On top there? Yes, no? Is it negative 8? Yeah. Is it? I heard it was. If it is, the final answer, my goodness, are you kidding? Answer's that. If that arithmetic's been done correctly. It's been done correctly. Okay, Anna, you think it's been done correctly? Okay. Okay, what's the next one?
F of square root of 2.
Nice, f of radical 2. Here we go, we'll replace up there, -2, radical 2 squared, plus radical 2, subtract 1. No problem. This is a -2. You know, if you square a square root of 2, you won't get merely 2. The square root drops off. These be this, these be this. Maybe an awkward looking answer. I'm gonna have -4 plus radical 2 minus 1. Guys, I'm gonna combine my numbers. I'm gonna write mine like this: -5 plus radical 2, if I have no mistake. And I'm done. That's all I'm gonna do. Okay, now they might graduate a little bit more demanding on us as he reads to me. What's the next one?
F of x minus 5.
F of x minus 5. You gotta be careful. Going back, got -2, x minus 5 squared plus x minus 5 minus 1. Let me step back, make sure I put all that in correctly. Looks good? Simplify this. Now, I know what you'd like to say. If I will simplify this, you might say x subtract 5, Professor, is x squared plus 25. It's not. What is it?
X squared.
What is x subtract 5 times x subtract 5 from Algebra 1, 5th grade?
X squared.
X squared
Plus 10x.
minus 10x plus 25. And then, of course, on the end, you still got this. Not hard, but just a little demanding here. And -1. Pull out my -1 again. Now clean this up, distribute the property out front, -2x squared plus 20x minus 50, if I have no mistake. Again, this and that. Just step back and look at it, make sure my signs are good. Collect like terms, looks like it's a -2x squared. Guys, the x's, looks like it's 21. And from where I'm standing, it looks like all my numbers will be a -56. You guys who are with me, is that making sense? I did it quickly. Is it? We combine everything? Okay, beautiful. Geez, that wasn't too bad. Now, what's the next one?
F of -4x.
F of a -4x. No problem. -2, -4x squared plus a -4x minus 1. Take them back here, replaced. Clean this up. Be very careful, guys. This is -2 times, I think this is 16x squared. Now, I still got this. I got that. Back out front, that's a -32x squared, just some math, minus 4x minus 1. Let me step back and look at it and see if you guys agree.
Yep.
Now that, I want to leave it like that. I don't see any like terms. Just leave it like you see it. Guy, what's the next one?
F of x plus h.
Oh, now, Anna, Mr. Park. I thought I would throw this in on the worksheet. This takes me into account situation, which we're not going all the way into since I'm not teaching calculus. But first, f of x plus h, same process. Take x plus h back, put it in, and I know, and you know, it's going to look like this. That's the way it looks. Now, if I clean this up, I'm going to be extra careful. This is -2 out front of that first term, guys. If you expand that, that's x squared plus what? 2xh. There you go, h squared. Still got this going on. Still got that. Distributive properties will not look that great, but here goes. A -2x squared minus 4xh minus 2h squared plus the x plus the h minus 1. Oh, Lord, why on earth, Randy, would you place that on the handout? Are there any like terms? I can't simplify this one. You're kidding. That's the answer. That's it. That is the answer. Now, I'll show you why I placed it. And Anna and Park will know why. Here it is, placed. Strange answer. And you got some of these on the exam on Friday. And so on Friday's exam, if you had this particular problem, this is the answer. You're done. Don't have to do anything else with it. Now, was that the last one on the handout? Okay. Was that the last on that page? Oh, there's more things to be done on the page, like find the domain. Okay, I want to do something before I find the domain. I'm going to take you right into calculus with that last example. I want to, on the side here, Anna, Park, I may have you guys to add some things to this. I'm going to put it down here. But now I'm going to venture into this. The f of x plus h. What on earth? They ask you now to do, and I'm going to show you what it looks like. I'm not teaching calculus. You're going to have in calculus this f of x plus h, like I had here. We're just going to add some more to it. They want you, for some reason, to now subtract f of x and then divide all that by h.
Oh, that was in the homework.
Oh, hang on, what's that?
That was in the homework.
Yeah, that's exactly in your textbook. That's what, and that's where you're going to lead into calculus. They don't do much with it, but they'd ask you to do it. Now, you say, Professor, when I finally reach Math 7, day 1, probably day 1, they may do this. Let's say it took this from Math 2, and they ask you to do a little bit more with it. Added some to it for some reason. They've got a reason. They've got a reason. Park or Anna, can you tell the class what this right here now extended into this, almost like a formula? Where's that taking me? Help me. That they should know in Math 7 when they finally get there, because I'm going to check on them in Math 7, I'll find them.
It leads to taking the derivative.
The derivative. So if you've had any calculus at all, or talked to someone who's had calculus, they probably mentioned the word derivative. 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 This is a start on a derivative. All I want to do as a Math 2 instructor, so you'll be ready, is to show you what this so-called thing looks like and apply it here in class, so you'll be ready. Now they give a name for it in class here. Math 2, they call this a difference quotient. A difference quotient. I'm gonna have a little fun with this. They don't call it derivative. You're not gonna see that word unless the author just mentions the derivative in your textbook. No, this is called a difference quotient. You go on into Math 7, they're gonna do a little bit more adjustment with this. Then they're gonna call it a derivative. That means you'll have this much done with me here in Math 2. Now, with that said, guys, we'll accept it like a formula. And it all stemmed from me doing this problem here. And I just did more to it. Now on the side here we go. I'd like to find this, the difference quotient for, I'm going to name a few functions for you. I'm going to start out with a basic function. I'm going to use that red formula and tell me the difference quotient. Here's my function. I'm going to start with a simple linear function. Now I want to find, with that red, that formula. I'm going to use that formula on that function and see what this so-called difference quotient looks like. Got your goes, let's go to the red. First it says in the red, find f of x plus h. That's the first thing I'm gonna find. Can anyone tell me what must I do on my example there? If they expect me to find f of x plus h, what would that mean for me to do on my function? Replace wherever the x is, or whatever the x is, replace it by x plus h. So we'll go to my function, 4, and in place of that x, no, they said replace it with an x plus h. That's what that means. And of course, we've got plus 5 remaining. I'm gonna block that off. Now, if you don't mind, this is my formula. I'm gonna mark this out for right now. That's done on this particular function. It says don't stop there. Now subtract from this. Now I'll get ready for it. Now it says subtract from it f of x. Now what should I put in for f of x in this case? The original function. They want the original function, f of x, which is 4x plus 5. I'll close that up, go back and lightly point out, that's done. And then do what to finish it up? Divide everything by h. And that's done. There's the difference quotient for that particular function, 4x plus 5. I'm gonna clean it up. Now as I clean it up, easily cleaned up here, watch what's gonna happen. Then I need a nice response from a student in this class. First I'm gonna clean it up. Distribute roughly 4x plus 4h. No problem. Plus 5. No problem. Down here, distribute the negative sign. Easily done. And make it 4x minus 5. All over h. I'm just trying to clean it up.